Hello and welcome to this presentation about if all you have is a hammer, which services should you use at Connect Online. My name is Michael. I'm part of the SDK team, and I'm going to talk you through all our different services and why and how and when you should use them, or maybe not. So agenda-wise, what we're going to cover today are two things. We'll mainly talk about the different services and their respective complexity. And then we'll also talk about useful patterns that you can use in your application as a starting point that will help you use the different services either together or one that helps make another one even better if you combine them. And then we'll jump into a Q&A session. But before we go into the specifics, I want to give you a practical motivating example from one thing I've been personally working on very recently. And when I built this deck, I figured that might be a very specific thing or a very interesting thing that you might like. So a little bit of context here. So I'm working on a thing called the Couchbase Sdk Dashboard, which is an internal application or application for me to look through our different SDKs that we have and compare their different API implementations in a standardized manner, and also look for certain compliance violations. As you know, with the Couchbase SDKs and our new SDK 3 in general, is we really care about consistency in terms of experience, while still making sure that we preserve the specifics of each language, right? And the goal with this dashboard here and the specific view that you're seeing is that so you can browse the different languages and then you can select different versions. So for example, for Java, you can browse the API for version 3.08, 3.07, and you can do the same thing for Node.js, etc. Now, why am I telling you this? So this is an application that's built in AngularJS and talks over GraphQL to Couchbase. And we'll specifically focus on two API calls that the front end makes to GraphQL, which in turn are turned to Couchbase queries. So the first one is, by default, we want to display the API for the newest versions for each language. So there is a GraphQL call named newest APIs, which will return, for example, for Java, it will say 3.08. For .NET, it will say 3.05, etc. Right? So basically, for each language, the newest version. And we need to extract it from the database. We'll talk about data model in a second. And then once we have a specific language selected, so on the screenshot here, you see Java, the Java client being marked as active and shown on the screen. We then lazily want to load the very specific API definitions for the language and version pair. So in this case, the language would be Java and the version would be 3.08, and then all the different APIs for bucket, collection, cluster, etc. would be loaded. And on the screenshot here, you see that the scope is open, which shows like an analytics query statement with the return value description, etc. If we look at the data model, I simplified it a little bit so that it fits on the screen and it works well, but you can imagine it like that. So there is I'm already using a preview feature of Couchbase called collections here. So there is a collection called signatures, and each signature has basically for each signature document, the document has, of course, an ID, like every document in Couchbase. And then it has certain properties, language, version, and then a huge list of signatures that are built from the API documentation. I've omitted the signatures so that it's easier to read, but you can imagine the signatures array on the right containing many different API calls. So for each SDK version, we have one document that it has a unique ID. And the way I decided to model it is that the document ID is unique with a pair of version and language. So the document for .NET version 3.05 has a document ID of .NET-3.0.5. And this is a way I'm able to locate it very quickly, as we'll see in a bit. And there are more than one document, of course, right? So for example, at the bottom screen, you see Java has two documents in here, one for 308 and one for 307, which will be important in a second. So that's our very simplistic data model that we'll work with here. So let's take our first core. So let me go back here. So basically the selecting the new, we have two cores we need to look at, right? We need to select all the newest APIs, and then we need to have one core that fetches the full API spec. So let's look at selecting the newest versions first. Because this is quite a complex query and it touches many documents, using the Nickel service makes sense, the query service with the Nickel language. And in this case, we run a Nickel query, which is a little bit complicated, but that's where Nickel really shines at. So since we have one document for each version and we want to fetch the newest one per version, the first thing we do is we'll select, so we'll select some data from our signatures collection, and then we'll group by language, right? So we'll basically, if we don't do anything else, but we rather group by language, what we'll get is we'll basically get Java, and then we'll get an array of versions, etc. Right? But what we want to do is we want to extract the newest one. So if you look inside our Nickel query here, we can see two nested array functions. So there is array aggregate and array max. So because the version will be an array of all the versions that are grouped by language. So in Java, we'll have an array which contains 307 and 308, let's say. Then we'll aggregate it and then select the max, the highest value. And Nickel will have a certain lexical ordering. And by grabbing the highest value, we'll get the newest one in this case. And now, because we want to use actually we want to turn the version into an ID we can then fetch from the KV store, what we'll do is we'll use the concat operation to combine the language, then use a dash, and then the version, which will return us something like Java-307 or something, right? And then we'll have a stream of newest versions. So we'll have Java-307, Java-308, .NET-305, etc. And what we'll then do is we'll run it against a Couchbase collection. So we'll perform a key value query and say, from our collection get, based on the ID, get the full content and return it to the GraphQL service. That's cool. So that's how we get all the entries for the newest version, so we can preload it. But now, if we go back again and say someone selects, instead of 308, which we just preloaded, selects 307 from the dropdown, then we need to go in and use the API call to load a very specific version. To do this, there are two ways to do it. The simple one that's shown on the screen here is just go to KV, because from our GraphQL API, we get two arguments. We get the language and we get the version. And then all we have to do is go to our KV service and say, okay, get me the document, and then we construct the document ID, language-version, fetch the document, and then return it as a structure that GraphQL understands to our endpoint. Now, why I'm highlighting this, and the reason is that if you're coming from a SQL background, you wouldn't, in this case, necessarily go for a KV call to fetch the document, but rather you would go in and say, select stuff from signatures where language equals Java and version equals 3.5, right? Which will give you the same end result, but as you'll see in a second, once we talk about the different services, if your Nickel query isn't covered, especially if you do a select star, it will have to go to the KV service anyways to fetch the document and then stream it back through the query engine to the client. But because we can construct our document ID from our domain logic, there is no need to go to Nickel. We can go to KV immediately instead, right? So that's a very motivating example, I think, where you can see that for certain types of queries, you want to go to Nickel, you want to go to analytics, you want to go to search, but then for others, you want to go to key value directly because it's faster, it's easier, and frankly, it's simpler, right? Because just calling signatures.get is much easier than constructing a Nickel query, sending it over, passing the rows, etc. So with this motivating example out of the way, let's take a step back and go through the individual services and talk about the individual complexity. So you might have seen this picture on our website, which talks about the different services and the different traits Couchbase server has, and the programming model and the security and everything. But in this talk, we're going to focus on a couple of services specifically. We'll talk about KV, we'll talk about query, analytics, full text search, and eventing. Now, as you can see, mobile and indexing are spelled out because from an SDK point of view, you don't talk to a mobile service directly. You will do that through Sync Gateway and Couchbase Lite. And the indexing service is also not talked to directly, but rather the query service in the background utilizes the indexing service to fulfill the queries. In terms of different semantics of the different services, as always in engineering, there are trade-offs, right? And it's not always clear-cut, but in my opinion, there are three different things you need to keep in mind when you compare different services and how to use them. And the trade-off there, in my opinion, are complexity, throughput, and latency. Now, you can design systems optimized for throughput, but then you might penalize latency, especially in the higher percentiles. And if you have a system that is very complex, it's, for example, very hard to achieve low latency usually, right? So throughput, latency, and complexity are a little bit at odds with each other. And we'll talk about the different services and how they relate to that scale. So as an overview, where is the domain complexity? And I'm specifically talking about domain complexity when you are using the service, because every service on the server side, it doesn't matter if it's search, key value, query, analytics, or eventing. Of course, those are complex code bases on the server side, right? What I'm talking about is the complexity that you have on the application side when streaming results back and using them, right? So how much complexity you need to have on your application side. So if we go from left to right, the ones where you probably have to have the most complexity pushed to the application is if you use the key value service. Because from a conceptual point of view, you need to know the document ID, as we've seen in the example before. And when you send the document ID to the server, it sends you a document back. And if you store a document, you also need to provide it the document ID and the content. The complexity starts when, let's say, you want to fetch more documents and then you aggregate them together and return a result, etc. Right? Now, in the middle, we have search and views. Now, search and views allow you to specify certain properties while you're querying. And in the view case, you have your map and your reduce function, which allows you to move some of your domain complexity on the server side. But in practice, you'll still likely do certain types of filtering and sorting and other capabilities on the application side. For example, with views, it's not possible to sort by value, only sort by key, right? And then once we go further right, both for query and analytics, because Nickel and SQL++ are so flexible, you can push a lot of the domain complexity into your Nickel query, and then you have to do less operations on the client side. Now, of course, depending on what you want to do, you still want to opt for pushing more complexity onto the application side and keeping your query simpler, maybe for faster execution. But there you can tune the knobs depending on your requirements. And then once we go to the eventing service, which we'll only touch on very briefly, since eventing is a purely server-side component, all the complexity is on the server side and you don't interact with it on the client through the SDK directly. So what is the role of the SDK in the first place? We have all these services. So we talked about data, key value. We talked about query, analytics, search, and views very briefly, but it is important to understand how or what role the SDK plays when talking to all of them. Now, one side of the equation is, of course, the SDK wants to make sure that all the APIs feel similar, right? So that when you do an analytics query or you do a nickel query, you have similar semantics, you have similar APIs to call. Now, what it abstracts from you are two things. The first thing it abstracts from you is the clustering of the system. So you use the SDK, it doesn't matter if it's a 1-node cluster or a 50-node Couchbase server cluster with services spread out through the system. The SDK will make sure it always sends the right operation to the right node. The other property that it abstracts from you are the implementation details on how to talk to the server. For example, the key value service, the data service, uses a custom binary protocol over a specific port that is highly optimized for low latency and high throughput. But it's not something that you can just talk over HTTP, for example. Then the other services, query, analytics, search, and views all talk over HTTP and send JSON back and forth. But first, they talk over different ports. And second, they all use a different payload structure. They're basically a different request and response structure, so they are not unified. This is another thing that the SDK does for you. It basically abstracts both the location and the implementation details of the individual services, and you can just use them from the clients as if they were using the same protocol. And I put eventing a little bit on the side here because technically the SDK doesn't talk to the eventing service directly, although we're currently in the process of adding the management APIs for eventing also into the client, so you can create functions, delete functions, etc. So we talked about the role of the SDK, but also briefly, let's touch on the role of your application. Now, you have to keep in mind that because you consume the SDK, and the SDK is part of the distributed system, that's Couchbase Server, your application is also part of the distributed system. So when you're developing an application, you must, of course, make sure to connect and disconnect properly and use the resources in the way they're intended to. You need to handle errors, catch exceptions, handle errors, decide what to do when they occur. You need to properly set up logging, diagnostics, GC information, etc. All those things that make sure that you're running your application in production in a safe and robust way and you're able to debug it if things go wrong. But then on top of that, your application should use and combine the different services as needed. So don't focus on one service, but rather use the one that fits your specific job the best. And then even if it's more efficient, think about moving logic to the client side as opposed to pushing it to the server side if it's efficient. And then of course, on the opposite side, if it's more efficient to push it to the server side, don't be afraid to do that as well. So let's start with the data service. The data service really focuses on high throughput and low latency. It's the fastest way to access documents in Couchbase Server by far. And I'm saying this because even when you go to analytics or you go to nickel or search, right, those services also ultimately get fed with data through the KV service, right? When you store a document, the only way to store a document in Couchbase Server is through the key value service. And then through eventually consistent indexes, all the other services over TCP get streamed the information and update their respective data structures. It's a very efficient binary protocol that has its origins in the memcached world. And you can use it to manipulate full and sub documents parts atomically. So you can store and retrieve documents as a whole, or you can choose through our sub document API to only modify or fetch parts of a specific document. And if you update a document, there is no global lock going on or anything. Every document is atomically on a per document basis. The important limitation to keep in mind is you need to have the document ID to fetch it. if you don't have the document ID, you need to go through services like query to fetch document IDs or fetch the contents of documents through, let's say, a where clause. And an index that backs it, of course. So here's an example on how to perform simple full document access. So on our collection, we have a method called insert, and insert takes, in the minimum case, a document ID and document content. You can also provide it options that allows to set synchronous durability requirements, etc. In this case, we perform the insert, and then when the operation succeeds, we print out the case value from our mutation result, which is part of the metadata that you can use to, for example, perform replace operations with optimistic concurrency. And because the semantics of insert say, hey, if the document already exists, don't store it, we'll get a document exists exception, and in our case, we just ignore it. And then on the retrieving side, we can call our collection.get with document ID, which returns as a collection result. And in our example here, we print the content that we just stored. And if we get a document not found exception, we ignore it as well here. But keep in mind, if the document is not found, you'll get an exception that you can handle properly. In addition to full document access, we can choose to also access parts of our document. So there are two methods called muted_in and lookup_in on the collection level. And the way it works is, at a minimum, there are two arguments. The first one is the document ID you want to mutate or lookup. And then you provide a list of specs. And for muted_in, they're called muted_in specs. And for lookup_in, they're called lookup_in specs. And the important part here is that each spec operates on a chunk of the document. So in our case here, we perform one operation against the cluster, but it contains two spec instructions to change the data. In our case here, we remove the section of a document that's under the path foo.bar, but at the same time, we also insert a JSON object at the location ABC in our JSON document. And then when we call lookup_in and we provide to lookup_in specs, we do two things. First, we get the content of the ABC location, but then we can also say with exists, does the path exist, right? So the result of the lookup_in result would contain two information snippets for us. The first one is the content of ABC, which is stored, and exists foo.bar will return false because we removed it in the previous operation. And there are many more operations available on muted_in. Please consult our documentation if you want to learn more. Climbing up the complexity ladder a little bit, let's talk about the view service. Now, let me first point out about the view service that the view service has been with Couchbase Server since 2.0, so for a long time. And even before we had Nickel, Analytics, Vortex Search, etc. So while it is still a great mechanism to perform certain operations against the cluster, most of its usefulness has already been subsumed, especially by Nickel and the very performant index structures it has in the background. What the view service is, it's basically distributed map reduce. So you write a map function, you write a reduce function, and then when data gets changed, the B-tree structure in the background will be updated. And then when you query it, the query operations are actually very efficient and they are scattered throughout the cluster. So it scales very well with the cluster size. It's very good for aggregations. The spatial support is in there but deprecated. But one of the main downsides of it is it's disk-based. That's why, especially performance-wise, the in-memory indexes that are coming with Nickel for most use cases are much faster than what you can do with the view service. Although the cool thing is you can write JavaScript code in your map and reduce functions, which makes them very capable of putting more of the logic you would write on the client side, put them into your map and reduce functions, and therefore move some complexity to the view service from your application there. Here's an example on how to perform a view query. So the view query lives at the bucket level. You need to give it the name of the design document and the name of the view. So a design document manages more than one or more views, and then optionally you can provide options. So in our case here, we query the view with the name view name in our design document design doc, and we limit the results by 10, and we also call the reduce function. And then once we perform the query, we print the number of total rows that were affected, and we also iterate our rows and print the data as JSON objects. So let's talk about the search service a little bit. The search service is again complexity-wise between data and query analytics, but it allows you to push some complexity into building the index, right? When you create a full text search index, you can be very flexible in how you create it, but maybe you need to do some post-processing or merging some data with other services when you retrieve the data. The way it works is there is a partitioned inverted index, which means that it scales with the cluster size. So if you add multiple search services, it also splits up the index in partitions and distributes them across the cluster. And then when you perform a search query, it will again do a scatter-getter like the view service. So it will send the SDK will send the request to one node, and then that one node will talk to the other search service nodes, put the information back together, and then stream it to the client. Now, it has very interesting capabilities, like it is language aware, so you can perform searches based on different languages. It has scoring capabilities. And in Couchbase Server 6.6 and later, we are adding support called Flex Index, which allows you to use the search service as an index source for Nickel. So you can write a Nickel query and underneath utilize the search service to retrieve some of the data, which gives very interesting capabilities in terms of combining the expressiveness of a Nickel statement with the type of very specific type of inverted index when it comes to searching text data. It also supports autocomplete, geospatial queries, etc. So it is very feature rich. And basically as a guidance, where you want to use it is when you need very explicit results, black and white, you reach for Nickel and its indexes in the background, and you really, most of the time, you know when you want to use the search service. So when you do fuzzy searching, or if you have, like if you want to do free-form searches, you enter some text and then you'll search the data, and what the search service will return you is it won't return match or no match, but it will rather return scoring, so that it will score the documents or the hits of higher relevance higher, and then you can use that information. So it's not black and white, it's more grayish. How can we query a search index? So at the cluster level, there is a search query method, and it requires the index name as a mandatory argument, and then the type of search query you want to perform. So in this case, we use the query string query, which very similar to, let's say you have a Google search box, right? You give it a free-form string, and then it will apply the query string against your index and return you the results. From the search service, we'll move on to the query service. And aside from the queries, aside from the key value service, the query service is definitely the most popular one when used with Couchbase Server. Especially if you're coming from a relational background, naturally Nickel, because it looks so much like SQL, is the natural tendency to go towards. So aside from the query language, when would you use the query service? You would, in my opinion, you will reach for the query service if you can't use the key value service because you don't know the primary index, or sorry, if you don't know the document ID, and you need some kind of index structure in the background with a where clause, etc., to basically scan many documents. it is very much optimized for online transactional processing, low latency queries, right? So as we'll see in a second, if you want to search billions of documents and aggregate certain things, you want to go to the analytics service instead. It has both a rule and cost-based optimizer. It is very familiar to SQL users because the Nickel language is so similar. And the execution pipeline is very powerful, but of course it's also complex. Again, trade-offs. So if you look at the architecture diagram in the bottom right corner, the interesting piece is what you'll see is that there is a scan phase after parsing and planning. There is a scan phase where the query service talks to the index service to fetch the information that it needs. And then there is the fetch phase, and the fetch phase, the query engine goes to the key value data service to fetch all the information that isn't part of the index, right? And then immediately gives you an idea that the query service can't be any faster than the key value service, because query usually has to go to key value to fetch some data, right? So there you immediately have some trade-offs here. But then of course, you get all the flexibility of applying joins, filtering your results, aggregating them, sorting them, limiting them, applying an offset, doing all the projections, right? All of the things that you can do with Nickel very easily, but pushing all of this onto the client side would be a big overhead, which is something you usually don't want to do. So how do we perform a Nickel query? At the cluster level, the Nickel query needs a mandatory statement and options. So here we have a Nickel statement, which does select stuff from app where name equals $name. And you can see that the API is very similar to what you find in relation databases. So you can use name parameters, you can use positional parameters. Here we set ad hoc to false, which will do prepared statements. So the statement will be prepared on the cluster, and then every subsequent operation will use the prepared plan and is going to be more efficient. And then we print some metadata that we got back from the result. We also stream our data and print every row. So going into the analytics service. The analytics service is really optimized for complex analytical queries, right? So we've really added the analytics service so that query performs OLTP type queries, and the analytics service picks up where the OLTP style indexes come to the limit, right? So the important part here is that you don't need to add different services to your ecosystem if you want to perform analytical operations on your primary data, right? So there is no extract, transform, and load platform needed, because the analytics indexes are streamed at the same rate, at the same time than your OLTP query indexes are. It's just that the data structures on the analytics service are very different and optimized for big, long-running queries that consumes a lot of resources, but still crunches through a lot of data very efficiently, right? So think of it as the big brother of the query service. And it's very important that usually you want, even though you can run the analytics service on the same node as with the other services, but usually you want to move the analytics service to a dedicated node in the cluster with only the analytics service enabled, because it's really meant for this like heavy data crunching, and naturally it wants to consume all the resources it can to do that very efficiently, right? And this is the cool thing about our multi-dimensional scalability, is that you can have your KV, which is very efficient, low latency, high throughput. Then you can have your query service on a different node in the cluster, which does your OLTP style queries. And then you have another node which runs the analytics service, which again does different things, but you all manage them the same way. And the SDK exposes all of it through the same API, right? You don't need 3 different systems that all talk different protocols and different APIs. It's basically one package for you to consume and use depending on your use case. And you can even start out saying, okay, I'll start with KV and query. And then 1 year down the road, you think, oh, I have a new use case where I need to do some heavy data crunching. No problem. Add an analytics node or more to your cluster. Create those analytics indexes in the background without impacting your front-end load, and then running analytics queries on top. How do we perform an analytics query? It's very similar to a nickel query. So you call cluster.analytics query, you give it your statement. Again, we support name parameters, positional parameters, and many more properties you'll find in our documentation. And then we run our query, which might take a long time, depending on how much data needs to be analyzed. And then we can print metadata, we can iterate our rows, etc. Work with it exactly the same way you would do with nickel. Last but not least, the eventing service. As I mentioned, the SDK doesn't really talk to the eventing service directly, so it's purely a server side in terms of complexity. And what it does is it runs JavaScript code on server events. And right now we support two server events. We support document mutations, so you can run an eventing function if a document changes, or you can run events when a timer fires, right? So on regular intervals, you can, let's say you can run some kind of cleanup job that goes through your data and performs some cleanup logic or something like that. The only way you can actually right now call out of the system is with a curl function that is also heavily guarded, but there is a way to call into external APIs. And the use cases there are like, you can modify enriched documents, you can set alerts, you can cascade deletes. Please check out our documentation for more information about the eventing service and what you can do with it. It's a really cool addition to add or push more logic to the server side, where the important part is like it runs on its own, right? You don't need to create a small Java application to, let's say, run this cleanup job if you can move it to an eventing function that is automatically backed up, etc. To close out, let's talk briefly about some useful patterns you can take as a starting point for your application. One of the interesting things, I think, with using the key value service combined with nickel is you can use the data service to cache results, right? As you probably know, we have different bucket types. So we have memcache buckets, we have Couchbase buckets, and we have ephemeral buckets. Now, memcache buckets traditionally have been used for memcached compatible systems, although they're certainly going away in popularity because ephemeral buckets give you the same in-memory only capabilities, but also allow you to run nickel queries, etc. on your data, which you couldn't do with memcache buckets. So the code you see here is so we connect to the cluster, and then we open a bucket called cache, and then we use the default collection on that cache. Now, if you look at the code, what the code does is it first goes to our cache collection and fetches the document user-1234. If the document is not found in our cache, we go to query. So basically we perform a nick query and say, select app.star from app where user equals $user. So we use named parameters. We take the content and then we refresh our cache. So we call collection.upset with the same ID, the content we just loaded from the database, and store it with an expiry of 60 seconds. So what this will do is it will basically, if the document will be cached for a minute, then it will be removed on the server side. And then when the next request comes along and doesn't find it, we'll repopulate the cache. And then the next hit will go to the cache again. So by combining nickel and KV, we can even build caches for aggregated results. And you can imagine using the same technique for, let's say you run a very expensive analytics query that takes 30 minutes to run, but the result is something you want to use as part of your hot code part of your application. No problem. You run your query, you take the result, you store it as a new document, and then you can use key value to fetch this document very efficiently and serve it to your users. Let's say you do ad targeting, right? For ad targeting, you have two objectives. The first thing is you want to do some heavy data crunching to figure out which ads belong to a certain user. But then when you fetch this information, it needs to be super quick because you want to show that ad very quickly to a user. So you would do an analytics query, you perform your ad targeting queries that may take a long time, are complex to create, but then you store the result information in Couchbase as a document. And then when you get a request from a website saying, I need the ad for that user, all you need to do is you do a KV query and fetch that document and return it. So one thing I mentioned before, and I want to emphasize, is that the query engine, if it doesn't have the data in a covered index, which is especially true if you do things like select star or you fetch full documents, it needs to go to the data service to get the actual content, put it in the pipeline, and then keep going. Now, there is one technique you can use to offload some of this logic to the client. And the reason you might want to consider doing this is that imagine you have one query service and 6 data nodes. Now, when you perform a query, a nickel query, it will do the fetch against all 6 data nodes, but then send it back to the one nickel query service, perform the operations, and then stream it back through the one socket, right? So basically, we only have a parallelism of our 6 data nodes inside the query pipeline, but then it gets serialized again into our single pipeline and then streamed back to the user, which is fine in some cases. But if you want to keep the parallelism, what you can do is you can perform a nickel query that only fetches the document ID. So you can do select meta.id as ID instead of select star, which will only return us the document ID. And because the document ID is always part of the index, it doesn't need to go to the key value store. It has it as part of its index. So it does select meta ID. It will go to the, let's say, primary index, and it will stream us the document IDs back into the client. And then the client, for each row it can get back, we can fetch the document over key value and talk to our 6 nodes directly. The result will be the same. We get the full documents for all our document IDs that match our where clause, but we've talked to the 6 data nodes directly instead of having a single funnel through the query service. Now, this is a synchronous and blocking code to illustrate the point, but it is not very efficient because we'll basically stream and then block on each fetch, which again doesn't buy us much more than going to the nickel service only, because there is no parallelism going on here. But we can take this and turn it into an asynchronous operation. So here we're using the Java Reactive Api, which allows us to run a parallel stream of asynchronous operations. So we are performing a reactive nickel query. It's exactly the same API. But what we can then do is, as our rows come flowing in from the server, we'll again go to the key value service by using our reactive API and then return the data. And what this will do is it will, as the IDs stream from our nickel response, from our query response, we're going to immediately, for each document ID we get back, send a request to the respective data service. So while the data is still streaming, we are already starting to send out key value operations as fast as we can, and then we collect the individual information back as quickly as we can and return it. What this has done is basically returned our, let's call it single-threaded nickel query into a massively parallel data fetching machine that really allows us to utilize our resources in a very efficient way and perform bulk fetching of full documents that is even faster than going to nickel alone. But then again, you see the trade-off here, right? If all we had to do would be select star, the complexity is pushed into the query engine, which makes our code simpler, because then all we have to do is iterate the rows and return it. But the trade-off is reduced performance. If you want to go for even higher performance, but you can't reach for key value alone, You can use a mixture of both, right? So we can only get the IDs and then add a little bit of client-side code, so we have more complexity on the client side, but get even more performance out of it. Again, depends on the use case, depends what you're wanting to do, but combining the different services and combining the tools that the clients give you really gives you a very rich tool set in your hand to decide based on your use case what you want to do with it. Now with that, I thank you very much for your attention.